Hello, this is Mrs. Boots, and we are going to go through the parent function practice problems. Excuse me. I know it looks like there's a lot of problems, but they're really short and simple. We're going to go through the first 5 real quick. So we have all the parent functions who have a domain of negative infinity to positive infinity. We're just going to go down the list and see which ones they are, alright? So you can use your notes for this. So the first one is linear, and so we're just going to write an L for linear, okay? Quadratic, does it have a domain? Yes. Infinity to infinity. Cubic? Yes, it does. Square root? Nope. Cube root? Yes, it does. Exponential. Exponential has a domain of infinity to infinity. Rational? No. And log? No. Okay? Same thing with second question. Which one has a domain that goes from 0 to infinity? Well, the only one I can think of is the square root function. Now you may say the log has it, but remember the log has a parenthesis, okay? So it doesn't count. Alright, now which parent functions have a range that goes infinity to infinity? Again, just go down the list. So we know linear does, cubic does, cube root does, and log. Okay? Which parent functions have a range from 0 to infinity? And the square root also has a range, 0 to infinity. And you may say, well, Mrs. Boots, what about the exponential? Remember, exponential is similar to that, but it has a parenthesis. Now, which parent functions have asymptotes? Okay, so the first one that comes to mind is our rational. The log has an asymptote and the exponential. So there are three that have asymptotes. Okay? Alright, so now let's look at the next 6 functions. Sorry, not the next 6 through 18. In 6 through 18, all of these problems, all we have to do is write the name, and we're just going to draw a little graph. Okay? So, number 6, I noticed that we have a square. The square tells us it is a quadratic, and the quadratic looks like a U shape. Okay? And number 7, we have these beautiful vertical bars. Vertical bars are the absolute value. Absolute value is a V shape. Short and easy. Number 8, we have this beautiful radical thing here. That's my square root function. And remember, it starts and it goes over and to the right. Number 9, looking at the equation, I noticed exponents. I always look for exponents and symbols. That's what we're doing, exponents and symbols, okay? I noticed there's a 3 in the exponent. 3 is cube. Cube goes up on the right and down on the left. It's supposed to meet in the middle right there. Okay. Number 10. Number 10 is a did giveaway. It has the word log. Guess what? It is a log. Number 11, we have vertical bars. That's an absolute value. That's our V shape. And I forgot to draw the log on number 10, so I'm going to go back and do that. Okay. Number 12, I have x in the denominator. Rational is fractional. So that's my rational function. Remember, rational function has the 2 curves that don't meet. 13, x is in the exponent, which makes it exponential. Exponential can go up and to the right, or it could go down and to the left, but we're going to do the up and to the right. 14, x is in the exponent, so it's an exponential. Up and to the right. 15, vertical bars. Vertical bars are absolute value. Absolute value is a V shape. Okay. 16, I have a radical, but there's a 3 with it. The 3 makes it a cube root. Cube root goes sideways. It's like a cube function going sideways. A little crazy to draw. 17, I have x in the denominator. Okay, so fractional is rational. So we have a rational function. Remember, this is the 2 curves. They're not supposed to cross or touch. And 18 is the tricky one because people see the fraction and they're like, oh, it's a fraction, it must be rational. But look at the x. There's no exponent and it's in the numerator. So that's just a straight linear. Good old straight line. No big deal. Okay? Okay, let's go down the page. Let's look at some of our graphs. The graphs are super easy. Again, we're just writing the name. And on these, we're going to also add the equation. So we're going to kind of go backwards a little bit. So the first one, I notice it's a U shape. All right? U shape. Remember that U shape? That means it's a quadratic. And the quadratic is y equals x squared. Okay? 20. Well, they usually go up and to the right, but I guess it could be flipped upside down, right? So that's a radical or a square root. Let me write that as square root. Some people call them a radical function, but it's a square root, and that's y equals square root of x. Okay, a little further down the page. 21, I have two separate pieces. Makes it a rational function. Okay, and that's y equals 1 over x. Number 20 has that beautiful V shape, so it's absolute value. And that's y equals, remember, value has the vertical bars. 23, straight line, super easy one. That's our linear. And remember, the simplest linear is just y equals x. 24 is our U shape again. We know the U shape is a quadratic. And that's y equals x squared. Okay, so now we're going to get down into the word problems. These are the fun ones. Okay, for each one of these, all we're going to do is put the letter as to which function it is. We're not even going to stop to do a graph or an equation, either one. We're just going to put our letter down there. Okay, so the height of a ball depends on the force at which it's thrown. So we're looking at height, right? Anytime I have a height of a ball, okay, so that's going to be a quadratic. The price you pay for a dozen eggs depends on the size. That's a linear. Okay, why is it linear? Because as the size go up, the price goes up. The amount of air pressure found in a standard car tire, as your temperature goes up and down, that tire pressure is going to change. It's a linear relationship. The condition of pavement on streets based on the amount of traffic passing over them. So think about it. The more pavement, the faster it breaks down. That's actually an exponential one. That was kind of fun to look up. Okay. The amount of air I feel from a ceiling fan. Another linear. There's lots of linears, by the way. Okay. The amount of curl in your hair related to the humidity. I actually have curly hair, and I can tell you a little bit of humidity goes a long way. So it's an exponential. Okay. The number of spins for a top. We actually gave that example. That's a cubic. Okay. The height of the football related to time. We've talked about that. That's our quadratic. The distance of students from the door. Okay. So it could be positive, could be negative, but is distance a positive or negative? No. Distance is always a positive. So that's our absolute value. The level of blood sugar. So for our diabetics, your blood sugar levels, that is an exponential function. So measuring the blood sugar levels in the bloodstream is an exponential, and the amount of insulin that gets injected and how often is controlled by exponential functions, which is really kind of cool. 11, the amount of taxes related to a person's income. Okay, now, I think this is a semi-bad example, but supposedly it's linear, right? The more money I make, the more taxes I pay. We're not talking about all the loopholes and all the little deductions, okay? The rate at which two people can paint a room, that is our rational. It's a group work rate. Okay, the amount of flavor left in a piece of chewing gum. Guess what? That's an exponential, right? Because, it's got a whole lot of flavor at the beginning, and then that flavor just decays down. Exponential decay. The number of rotations a sprinkler makes. Okay, well, a sprinkler has a standard rate of rotation, so anything that has a constant rate is linear. The height of the home run hit in baseball? Quadratic. We hit the ball. The growth of your ears related to your age. I think that's kind of gross, but they say it happens. That is an exponential. Alright. Your heart rate when you're sleeping is an example of a linear function because it's supposed to be constant. Okay. The number of moths around a light bulb relating to the brightness of the bulb. That's actually irrational. That was a fun one to read about. So if you're interested in moths and light bulbs, you can Google it. The life expectancy of a smoker related to the number of packs of cigarettes. That is an exponential decay. The more they smoke, the faster it kills them. The amount of ink left in a pen. Depends on the ink pen. But yes, it is a linear. It's supposed to be a constant rate. The number of bacteria. We talked about bacteria infecting the body. That was an exponential one. Magnetic field related to distance. There's our cubic. Okay, the amount of time it takes for students to walk to class, and I'm talking about your normal students. Can time be negative? No. Time's always positive. That makes it an absolute value. And the price of eggs related to time. That's the weird part. If I'm talking about the price of eggs related to size, it's linear. But related to time, it's actually an exponential because it goes up in that pattern. That's the model that fits it. And this concludes all of our practice problems on just identifying the parent function based on different criteria.